Hello everyone, my name is Cornelius Brian from the Department of Information Technology at Chaoyang University of Technology. Today I will be presenting my final project titled The Creation of an IoT Technology that Improves Water Quality According to WHO Standards. This project focuses on using the IoT-enabled RC to monitor water quality in real time. Okay, next. From the introduction is that water pollution is like a serious global issue that caused mainly by industrial activities and human waste. Poor water quality can harm the aquatic life and also pose risks to human health. Traditional water monitoring methods are usually manual, slow, and limited to specific locations. But because of this, IoT technology offers a better solution by enabling the real-time and remote water quality monitoring. Now, the main objective of this project is to design an IoT-based RC boot that can measure the water quality parameters. The parameters include the temperature, pH, and turbidity. The collected data is transmitted in real time and compared with the World Health Organization standards to determine whether the water is clean or polluted. So this is the system architecture. This this shows the system architecture of the project. The RC board acts as a mobile platform that carries the sensors. The sensors measure the temperature, pH, and turbidity, and the microcontroller processes the sensor data and sends it wirelessly to a web-based interface where the data can be monitored in real time. Next is the methodology. The study uses the quantitative research approach focusing on numerical census data. The board is deployed on 3 different water locations and measurements are taken at each spot. The collected data is then analyzed and compared against the WHO water quality standards to evaluate the condition of the water. There's also the sample experiment data. For the evaluation, I use sample experiment data from a published IoT RC put study. This data put a dataset includes temperature, pH, and turbidity readings from multiple samples. This allows us to objectively compare real sensor data with WHO guidelines. And here is the example, the sunlight entry temperature, turbidity, and the pH. Yes, so according to the WHO guidelines, the acceptable pH levels are between 6.5 until 8.5. Turbidity should ideally be below 5 NTU, and lower water temperatures are generally preferred. These standards are used as a benchmark for evaluating the sample data. So this is the result comparison. The first sample is met with pH and turbidity standards. Is the It shows that most samples failed to meet the guidelines. Only one sample partially met the standards for pH and turbidity. And the main reason for this failure was the very high turbidity levels, which strongly indicate that the water is polluted. So, in the discussion, it was confirmed that turbidity is the most critical indicator of the water pollution. The high turbidity increases the health risk and affects the aquatic ecosystems. And our ecosystem provides an efficient, low-cost, and flexible method for monitoring water quality, especially in remote areas. And here, in the conclusion, we can see that in the project successfully create the IoT-based RP system for real-time water quality monitoring. Even when temperature and the pH appear acceptable to be detected and reveal hidden pollution risks. The system can support infallible monitoring and decision making. For future work, the system can be improved by adding more sensors such as the soft oxygen integrating GPS for water monitoring and applying machine learning for pollution prediction. Thank you for your attention.